Easy. Hey, how's it going?
Hey man, it's going fine. How are you?
Good. How do I say your name?
Oof, that's kinda. It's
Oof.
Vuk. Vuk.
Oof.
Vuk.
Vuk.
VUK. Yeah.
Okay, Vuk. Awesome name.
Yeah, thanks, man. It's kind of
Cool.
hard for foreigners, because it's like super Slavic.
Oh, cool. That's a badass name. Um, where are you calling from?
Yeah, I'm calling from Serbia.
From Serbia. Okay. So it must be late afternoon for you over there?
Yep.
Cool, nice. How's your day going?
Yeah, it's going fine, man. This is like Friday right now. The school is over. Everything is, great.
Cool. What school are you in?
I'm in gymnasium, so it's like a high school.
Oh, wow, cool. Man, I looked at your open source project and I would have expected that you're in at least university by now.
Yeah, we have like majors in our high schools, so I'm kind of like an IT major. So a lot of stuff that we're doing is basically college level.
Oh, damn. So when you're doing IT, what is that? Is that include computer science in it?
Yeah. It's information technologies, so it includes like telecommunication and computer science.
Okay. Did you learn how to program in this school?
Yeah. We started off with C around 3 years ago in our freshman year, and then we went to like C++, and now we're doing a bunch of stuff like everything from Spring Boot to web development.
Oh, cool. Yeah. I haven't used Spring Boot, but that sounds cool. If you then you also is that with Java?
Yeah.
Well, that's with Java. Okay, so C, C++, Java. Wow, that's so cool. And do people in Serbia in general get this opportunity?
Most people don't. Usually, you have to pass like a test or something, and you
Mhm.
have to like kind of be interested, in
Okay,
math and stuff to do it. So yeah.
awesome, cool. And the project that you're working on is cancer detection, right?
Yep.
How did you choose that?
Yeah, we're just kind of looking for an interesting project.
Uh-huh.
I just wanted something I've never done before, and I kind of like the medical field. And basically, just like one day, I heard that you can like detect cancer with like an AI. I was like, holy crap, that's crazy. And then I
Mm-hmm.
decided to do a skin cancer detection because it's most user friendly thing.
Cool. So is this graded for you?
No, this is just something I do in my free time.
Okay, it's for fun. And awesome. So what's your intended like end state? Do you want to ship it as I think you mentioned you want to ship it as a mobile app, right?
Yeah,
Cool. Awesome. On the Play Store?
yeah, and I also want to publish it on the iOS store, but like later on.
Cool. Awesome. So yeah, I think what would be really, really cool, especially like to put this on my channel would be like if you would maybe just walk me through the open source project that you have right now on GitHub. Because it's really cool and I think a lot of people could learn from it.
Sure. So you want me to stream my screen?
Yeah,
Okay.
cool.
Yeah, just a quick disclaimer, my PC isn't the fastest.
I'll wait until you're all set up.
Yeah. Yeah, especially right now I'm using Docker, so it's taking some RAM.
Oh, what are you running on Docker?
I'm trying to compile my model on Docker
Oh,
because it's easier, like I'm using Linux, so NVIDIA is kind of hard to
yeah. Oh,
set
yeah.
up.
I recently saw a YouTube video where Linus Torvalds said comments on the situation with NVIDIA. Did you see that one too?
Yeah, when he said F NVIDIA, yeah.
Yeah. Um, yeah. So you're using Docker to compile the model, and is that training?
Yeah, basically to train it, and also later on I'm gonna ship it on the cloud. But for now, I just wanna compile it and put it, on the client side. Load it inside React Native.
Okay, cool. And this is on GitHub. Um, let me see if I can. Yeah, I have the link here. So I'm just gonna paste that down here so other people can go to it. Um, cool. Yeah, actually, would you mind just going through the README real quick because you have like a really perfect README.
Yeah, I kind of try to include as much emojis as possible.
Yeah, that's
Uh,
probably what makes it for me. But I also think, but I also think like it's 10 out of 10 README as far as like, an example project.
oh yeah, thank you. Yeah, I try to make it like simple because there's around 5 other people who are participating in this. So yeah, I kind of had to make sure everyone can just go
Mhm.
through it and see how they can contribute to it.
And
Okay.
how is the team organized?
Well, basically, we have a Discord channel, and around a week ago, we kind of stopped meeting. But before that, for like around 2 months,
Hmm.
we would meet like every other day. So there would be like 5 of us in the voice channel, and we would just like discuss all the stuff we're doing, and we try to kind of like emulate a working environment.
And where do these people come from? From your school?
No, no, no. Most of them are like from US. So we had
Cool.
a few students from UCSD, one guy from UPenn, and one guy from USF, which is
Oh,
like
cool.
University of South
Nice.
Florida.
Cool.
Okay, so I just wanted to let you know for some reason it's kind of crashing right now. Would you mind me just like restarting the PC and like joining in like 5 minutes maybe?
Yeah, for sure. I was just thinking like what else you could do is I mean, I can also open up the code on my screen, but then you would need to you'd still need to restart your PC anyways, right?
Yeah, because like right now it's frozen for some reason. I mean, I just
Sure.
forgot to like
Yeah, sure.
close the. Okay,
Yeah, no worries. Go ahead.
see you in a minute, I guess.
Yeah. Okay, so this is an open source project dedicated to helping people living in regions with a lack of dermatologists. We've developed a skin cancer detection app using React Native for the front end and TensorFlow, NumPy, and Python for the back end. Let's see. The app empowers users to check if a mole is benign or malignant. Yeah, so I'm just waiting for Fook right now because he had to reboot his laptop, but he will be back in 1 minute, and we will be going through the rest of the code for this melanoma detector project, which is a project which he is working on with other high schoolers actually around the world. Hey, how's it going? Welcome. Where are you joining us from? So yeah, just for the new ones who just joined, Vuk is guiding me through this melanoma detector that he's developing with some other high schoolers around the world. And he's going to be making this into a mobile app. He's actually already made it into a mobile app that's working. But we are going to be actually working on localizing the AI model so that it can run on any phone without needing to upload any of the mole pictures onto the cloud. So that's sort of what we're going to be working together on. And right now he's he's rebooting his laptop, so he will be awesome. How's everything going in Kazakhstan today? Let's see. So brand here can show a. Let's see if we can do this. Add an overlay. Huh? It's okay? Okay. Cool. Are you building anything over there? Coding? Coding anything today? You have any cool projects going on? So we have the camera integration, captures photos directly from your phone's camera, real-time detection, and then that sends the photo to TensorFlow model, which is right now running on, I'm not sure where he said it's running on. It's running on a cloud provider. And machine learning magic. Yeah. So that model itself is trained with maybe he's using TensorFlow, NumPy, and Python. So I'll be really interested. It's yeah, it's also run with TensorFlow right now on the cloud, and we will be using TensorFlow.js today, which allows you to run any TensorFlow model on a device just by importing a JavaScript library. There he is. Hey,
What's up?
you're back.
Yep, sorry for this one.
Welcome back. No, I've just been reading your README to the to a couple of viewers that we had pop in while you were gone.
Awesome. And is there any like thing, anything like unclear with it?
I didn't get that far down, but I think yeah, no, I think it's a good overview. I'm just curious about how you use like yeah, like how do you use TensorFlow and NumPy together?
Well, you mostly use both.
Yeah.
You have a machine learning project because NumPy allows you to transform the data sets. In this case, we're using images, so we need to transform them from a 4D image, a 4D tensor, into a 2D tensor because I'm also using a mobile net, which is an architecture built with Google. So yeah, you need NumPy to transform, the data.
What type of neural network is MobileNet? Is that a R a s- what type of neural network is that?
It's a convolutional neural network.
Convolution. Okay, cool.
Uh, okay. Also, I want to share the research paper that we used
Sure. Here you
for
go.
building this. Um, so our architecture is mostly based off of this research paper. Can you see it?
Yeah, I can see it. Maybe you can zoom in just a bit more. Cool.
So as you can see, we are taking in images from the ham dataset. It's a dataset made by Harvard. And
Yeah.
basically, we just crop them, take out the region of interest so that only the mole is visible. We also apply some like blurring so we don't see, any hair or any like redness around the spot. And then we feed our images into two parts. So one is the part which is made like already made for us. It's MobileNet, right? We just put in the cropped image into it,
Hmm.
and then it extracts the deep learning features. And
Hmm.
the other part is manual or handcrafted feature extraction, where we take in the image and then we apply some math formulas to figure out the values of handcrafted features. And
Hmm.
basically, we combine those two using mutual information theory. So it's again a bit more of math, and then it feed it into the logistic regression, support vector machine, and I think robust vector machine, something like that. These three classifiers to see if it's benign or malignant.
Cool. So the mobile net is just the CNN part, right?
Yep.
And then the handcraft features, like who came up with those?
Well, these guys did. But usually the handcrafted features are used by doctors or physicians. They can
Right.
basically, just take a look at the mole and
Okay.
say, you
Is
know,
it is it round?
yeah,
What do the edges look like? Cool.
yeah, exactly.
Wow, I'm learning so much right now.
Yeah, I mean, for me, it's pretty interesting because you can also take this architecture and apply it into so many different issues. So also for brain tumor like classification or any other like X-ray or something like that. You just need to tune the handcrafted feature extractor.
Yeah, right. Anything that's like um, a fairly simple kind of image, I guess, that you want to
Yeah.
classify. Yeah, cool. That's super cool. Yeah, hey, Pawan, thanks for joining us. Cool. Yeah, so just walk me through like what are the key parts of the code here? I guess you probably have something for training and then something for running the model.
Yeah. So do you want to start off with the front end or with the model?
Oh, I'd like to see the model. I think that's really, really cool.
Yeah, sure. So the first part is the image crop and the binary mask.
Mm-hmm.
So let me see where this starts. Yeah, it's also like pretty well documented. We put a lot of effort into the documentation, so just by reading you can like see a lot of the stuff. So we take in a JPEG image and
Mm-hmm.
we output the cropped image, inverted image, and the binary mask. So the binary mask is basically taking away all the color from the image
Mhm.
and just replacing it with zeros and ones. So we get like this shape, right?
Oh, okay.
And we use that to calculate the area, the roundness, the symmetry, and those types of stuff.
Got it.
Um, let me show you. So here, this is one of the main functions. We take in the image path, we read the image. We're using OpenCV, just imread function. And basically after that, we feed it into the pre-processed image.
Mm-hmm.
This is the part which blurs the image and converts it into seal. So we have, when it comes to like images, several different ways of representing an image. Some of the ways are like RGB, seal. You also have grayscale. So usually for medical imaging, we use the seal because it's
Okay.
like way more reliable than RGB. From what I can understand, there's a lot of
Wow.
reasons why it is the way it is, but
Mhm.
it's on the research paper. So if you are interested in that, you can take a look.
Sure.
Anyways, after like pre-processing the image, which consists of just like blurring the image and also resizing it, we go into the generation of binary mask. So there's a method called the threshold in CV, OpenCV, which takes in the gray image and just checks for the thresholds of the image. So basically, we go over every single pixel here and we
Mm-hmm.
calculate the mean. I mean, not we, the OpenCV does that for us. And after we calculate the mean, we compare the pixels. Like again, we go over like every single pixel,
Mm-hmm.
and we compare like the value of the local pixels with the average. And if it's above the average, we can use the thresholding technique to just put like a one there, right? So we can just like how do you say that?
Right.
Just just make sure that we know this spot is like a part of the border or like the stuff that is important, right? It's above average. So
How far above the average does it have to be? Are you using like a standard deviation type of thing, or
yeah, we
just
use standard deviation for this.
okay? Cool.
You can also fine tune it, but OpenCV uses standard deviation.
Cool.
Um, and then basically you return the binary mask, which is just a numpy array, and it's a 40 numpy array, I believe. After that, you can also crop the image. Cropping of the image is a bit more tricky because sometimes we are unable to do so correctly. It all depends on the image quality. So basically, this function returns a tuple. It contains the original image, the binary mask, and the boolean, which says if the image can be processed. So sometimes we will just be unable to process the image because the quality is super low. Sometimes the image is too dark or too bright, and we just cannot extract the contours of the image, of the model. So let me see. Okay,
Okay,
fine.
cool. Yeah, I'm already very curious how you're going to make this all run locally on the device. Um,
Yeah, it's kind of complicated. Basically, this part is gonna be included. So we're gonna do the image cropping first
yeah,
in React, and then send the cropped NumPy arrays to the model.
got it.
So yeah, we're still figuring it out. But yeah, basically we're just gonna load it. I think there's a native file explorer or a library like that, which just uses these binary files. I mean, we compile this into a binary file, then that library will deal with it.
Wow.
Um,
Okay.
yeah, we're
Got it.
just uh-huh.
And does that get and that's separate or together with the neural network with the CNN?
That's separate.
Separate. Oh, okay.
Yeah,
Okay.
because I couldn't find a solution to compile this part into the neural network, because this doesn't use, TensorFlow or any library, or, which is a machine learning library.
Yeah, that's tricky. Okay. So you're going to be doing your idea is that in the JavaScript actually to do the fusion, so to say.
Yeah, well, basically in JavaScript, we're just cropping the image the user
Okay.
takes, and then we're sending those arrays. So we're not doing the fusion in the JavaScript part. We're doing it in the model part. We're just pre-processing inside the JavaScript. I mean, on the front end.
Okay, cool. Um, sorry for interrupting.
No, no,
I'll
no. Go
essentially
ahead. Like,
answer them all.
yeah, like if you have any questions, just feel free to
Yeah.
stop me. So we're finding contours of the binary mask, and basically this is going into machine vision or computer vision to be exact. And OpenCV just abstracts all the math behind it. But contours are similar to the borders, except that it's basically putting not just like a line wherever the pixel is greater than the average, or the values of the pixel are greater than the average values, but it's kind of mapping a border, right? Like it's taking a bunch of dots and it's saying like, okay, from this part of the image, like let's say this part, um, the values right of this pixel are greater than the average. So just like
Mhm.
putting a one here, like all around the border, right? And basically it's like an array. Um, it's actually, yeah, matrix. A matrix is which is like mapping all of these like little dots.
Mhm.
We're using that to calculate the border rectangle, or like the largest. Let me see, how should I phrase this? Like the largest possible like circle, if that makes sense.
The
Like
largest possible circle that fits inside.
yeah, yeah, we're calculating like the differences between those dots and like the distances, and basically we're saying like, okay, yeah, well, here as you can see we have like multiple, like, how do you say, the candidates for a contour, like this one and maybe this one, but it's the area will be greater if you do this one and this one, so it will draw a line here instead of drawing a line here.
Mhm. Oh, okay.
And after doing that,
Yeah, that makes
we're
sense.
making sure that the size of the image which is cropped is less than the dimensions of the original image. Sometimes it happens that the whole image, oh my god, Grammarly, the whole image is covering, like, let's just get rid of Grammarly. Like, I got one image which is basically like the whole image is a mole, right? And if we try to crop it, we'll crop a smaller part of the mole, and we don't want that. So here we're just setting the, okay, yeah, these are the extreme values. So the x value which is closest to the, how to say that, the base, like this point, the starting point of the image, and the y value which is this like greatest, the closest one to the y-axis, or like the smallest y, and then we're also finding the biggest y and the biggest x, and we do that in order to crop. Does that make sense?
What I understand is you're finding the box that you need to crop around the mole. That's it, right?
Yeah, and just we're testing every single contour, and comparing its x and y values to see like if we can make like the biggest box possible.
The biggest box possible.
Yeah, because we don't want to like crop up some part of the mole off. We just want to take in as much of the mole as possible.
Right.
Yeah, after doing that, yeah, use the bounding rectangle function. After doing that, we're just computing the dimensions with the buffer, and we're making sure also if the mole is like slightly off center, that we don't put it in the middle of the image, which is an issue because let's say the mole is slightly off to the right. If we put it in the middle, we might get like a bunch of black pixels like on the right screen, like the image might not exist, right? So we're just making sure that the image exists around the cropped image, like the
Okay.
cropped region of interest.
Got it.
And here, yep, we're cropping the image here. We're taking the Y, which is the smallest Y version, or like the smallest Y value of the contour, and the biggest Y, or like the side length. Yeah, the side length. We're calculating the buffer here. And also we're doing the same for the X, and that's the cropped image. We're doing the same for the binary mask. We just like calculate the binary mask before that, but then we're cropping it here again. And yeah, here we're checking if the binary mask is like completely white or completely black. So
Yeah,
using a
you,
NumPy.
So there's actually a question from someone who's watching. I don't actually fully understand it. It's from Saraf, who said, can you quantize the model and do inferencing on the front end with ONNX? I don't know what ONNX is.
I'm not sure, to be honest.
Yeah.
Can he like explain that a bit more?
Yeah, you'll have to explain that a bit more for us.
ONNX. That seems interesting. Open Neural Network Exchange. Yeah, it's just a company from what I can see. I've never heard of it. And can you explain like what does quantize mean?
Right. Yeah.
Yeah,
Anyways,
I'm waiting for that. Yeah.
I'll let you.
Yeah, but it's interesting. Yeah, and after seeing if it's like completely white or completely black, we're returning a tuple which says, hey, the image is not properly taken. Later on, we're going to use this bit of the tuple in the front end to just, return an error. We're also inverting the colors. We try to experiment with inverting the colors, but there are several issues with it. So we're probably not going to use them for the model. Yeah, and this part is for saving the cropped images, which we don't really need to do if we're making a mobile app. This is just for training and testing the stuff. This is a very simple function which just consists of imwrites, and that's basically it. Like we're using this method, which is made in OpenCV again, to just compile the whole NumPy array into like this file name.
Okay.
And yeah, that's basically it. I'm using a parser to just add a few arguments when I'm like training the model. So I'll say like, hey, crop the binary mask and images of this folder, right? Because we're doing testing on multiple data sets, and it's kind of hard to compile it for every like data set. And I just like change the value, the location of the data set here. Are there any questions? Like I wrote this like a few weeks ago, so I didn't, I'm not most prepared for this.
No, that's super cool. Honestly, I've never written anything anything like this. I'm not a machine learning or a data scientist myself, but that's super cool to see. And then what about the so that's like the normal image processing part about, and for the other part of the model, the TensorFlow.
It's model crafted.py, this file. We're using MobileNet. We're importing. We could also use just Keras instead of TensorFlow, but it's the fact that TensorFlow is easily computable with CUDA, whereas Keras takes a bit more setting up or setup. So that's why we chose TensorFlow. But basically, we just import MobileNet with all the weights, and we're using the ImageNet weights. And here we're specifying the input shape, and we're doing the 224 times 224. Also, I'm using image data generator to normalize the images. So every single pixel is divided by 225. So there's like less computing. I'm setting the batch size to 32. Some people are like going lower, especially if you have like a verse PC, you should go lower, but it will take like a bit more time to compute. And basically, all I'm doing here is using this function, which resizes the cropped image to fit inside the model's input size, and then giving out predictions, and then just returning the features. So the predictions of this model are actually the features, because I specified not to include the top part. And if you take a look, let me see if I can run this. Basically, if you take a look at the mobile.summary or the architecture of MobileNet, it's just convolutional neural net. I mean, convolutional. How do you say that? Steps. And at the end, they use a flatten function and also a dense function. So we're just excluding the dense part, because we don't want to use its predictions. We just want the MobileNet to extract features.
Okay, and then what do those features get passed on to?
They get passed on to the fusion stage.
Got it, right.
Yeah.
Cool. And that one we haven't gone through. Okay.
Okay, this is interesting. Image data. I'll take a look at this. Probably, yeah, I didn't import. Yep, I didn't do this. Or did I? Never mind. So here, let me see where we are starting. Cropped image, binary mask. Like, this is taking the cropped image and the binary mask. Yeah, this is one of the most important functions, which is wrapping the features together. We're taking the binary mask, the handcrafted features, and deep learning features. I mean, we're using the binary mask to get the handcrafted features, right? But basically, we just concatenate these two arrays. They're both NumPy arrays. And then we return the extracted features, and we're using these three classifiers, and I'm making them compete with each other to give out the best classifier, and then we're going to use that one.
Oh, so you have how many different classifiers?
3.
Okay. And you only choose one at the end, the one that works the best?
Yeah.
Okay. Oh, interesting. And then you'll use that one for the finished application.
Yeah.
Oh, that's super interesting. Cool. So this is what Saurav said. He said quantize reduces the size of the model, and then you can run it. ONNX allows you to port it to different frameworks. So PyTorch, TensorFlow, Cafe. Interesting.
Yeah, that's definitely interesting. Yeah, I would love to hear like a bit more from you.
Yeah, so
About
you're welcome to join us. You're also welcome to join us on the stream as well if you'd like to join. If you'd like to chip into the conversation. Sounds like you're much more qualified in this area than I am. So yeah, basically, I mean, I do a lot of full stack, but I thought, oh, it would be really cool to see the model first, so we know what we're dealing with. I've wanted to get into doing TensorFlow.js myself, so I think this is a really cool project. Yeah, but it's also a pretty big project, so I guess we'll just see where we get. What have you kind of considered so far? Or tell me more about your process of getting all these models from the cloud onto the local device?
So I try to use the pip install to configure um, compiling the model with the GPU, because CPU is always too slow for this stuff. So people use GPUs, and
Hmm.
CUDA from NVIDIA is like the most compatible library with TensorFlow, and
Yeah.
also PyTorch, I think. Yeah, I don't
Yeah.
think MEMD is like the best for this. But basically, we try to like deploy this on the clouds on Hugging Face,
Hmm.
and more or less everything was working fine until we saw there was a GDPR, I think, bill from EU, which says that we need a certificate to send biometric information about the
Right.
users
Right.
to the server. So we're not allowed to do that, and I didn't want to get a strike from the Play Store. So basically, right now we're just trying to compile it on the mobile device. The only difference is that, I mean, I still have to build a Docker container and everything. The
Hmm.
only difference is that we need to optimize it a bit more for React Native and just reduce the size. And that's why I'm super interested in quantitizing the model, as Saurav said. And also, we cannot just use the server side. So I need to figure out a way that I can just get predictions in the context API, probably,
Right.
from React Native.
So the app is working great now, but you have to do the whole thing without passing any images to the server.
Yeah, basically.
All right. And yeah, can you show me how you do that? How you're doing that compilation?
I would just take the, let me see. Yep, Docker desktop.
Yeah. And why do you do it in Docker?
Well, Linux, especially Mint,
Hmm.
which I'm using, is
Yeah.
not very compatible with NVIDIA, so
Right.
it's super hard to configure it. And a lot of the packages are not well maintained, so they malfunction all the time. And Docker is the most reliable option. I just copied the TensorFlow's image, um, and or like pull the TensorFlow's image and basically run my container with the image included.
Okay. So you're
Something
using Windows on Docker to compile your models with Python and TensorFlow into a binary?
I think it's actually Linux again.
Oh, oh, it's
Or
just
no,
a
no, no, no. It's probably yeah, it's probably actually Windows. I'm not sure. Like, 'cause
yeah.
I just pulled it,
Okay.
and yeah, it's kind of confusing.
Which Docker image is it?
This one, TensorFlow latest GPU Jupyter.
Okay, yeah. Okay, so something that works with TensorFlow. Okay,
Yeah,
interesting.
you have it on the like documentation.
Crazy. Okay. All right.
I'm kind of afraid of doing this.
Right
Well,
now.
yeah, I think my PC will like slow down considerably again, and I might have to like restart it.
Um, I could
So,
um, I could spin up an EC2 instance for you potentially. I don't know if that'd be helpful.
mm,
Like,
can you wait? What's an easy two?
so basically, um, I have some credits with AWS, so I could just so it's basically a Docker container running on AWS.
Uh-huh. Uh-huh.
I don't know if
Well,
that
maybe
might be helpful for you.
sure. I'm just not sure how can I like transfer the image to you. Like you
Right.
would need to pull the TensorFlow image, and after that, I would need to. I guess you would need to clone the repository, right? And use the Docker init um, to
Yeah.
initialize Docker on the repository.
Yeah, that's not, if it's worthwhile, that's definitely something we could do because um, I'm not using those credits. So that would be great. Um, how long does it take you to compile right now?
Oh, usually it's like at least 3 hours.
Oh, really? And Do you need to do that a lot?
No, I tend to do it on the weekends only. So, like, once a week or twice a week, and that's it.
What's okay, yeah, and that's running on your local machine. So like, what's the um, what's yeah, what are the specs like on your laptop?
I'm using PC actually, which not PC, like yeah, PC. GTX 1060, 6 GB, and an i5 3570.
How much processing power is on the i5? Or
Uh, when I went like to the benchmark website, it says like 4,000 points, so that's all I know about it. Um,
do you, yeah, I'm just wondering, do you think like you would need to compile it faster? Would you need more RAM or would you need like a faster CPU?
I would need more RAM because I'm trying to, at least on Docker, I'm trying to compile it using the GPU, which is, I think, sufficient. Yeah, I'm not sure if I would recommend you use all your like credits right now, but let's say if we can like maybe meet again,
No,
and
yeah.
I can just tweak a little bit the
No,
thing.
I'm just curious because these are so this one, like the T2 2X large, that has 32 gigabytes of RAM. Um, right. And then it costs me or whoever 37 cents an hour. Um, which yeah, which is if I don't it's just free, you know. So it's not going to use all my credits. um, but it's like you said, it's the time that it would take to get this set up and then to get it all set up on the EC2 container, which could take an entire day, you know, if things don't go well, right?
Yeah, and
So
they often don't go well.
yeah, for some reason, it never seems to go well. um, yeah, I have done this once before, but it was more just a thought, like, oh, if it becomes like a serious issue, um, I love finding ways to spend it to spend the AWS credits. Um,
Yeah, that would be nice.
so Sarov says, what's the size of the model?
I think after reducing the size, using TensorFlow Lite, it's around like 12 megabytes.
12 megabytes.
Yep.
Okay.
So, um, hmm, let me see if I have it in the notebooks. I don't think so. Yeah, we deleted all the stuff.
Okay. And
Never
what's
mind.
this?
Yeah, I had it like the size.
And what's the stage that you're at now with integrating this into the well, it's a React Native application.
Yeah, when it comes to like integration, we're still far off because we focused on the whole idea of computing it on the cloud.
Yeah.
So we haven't even started looking into the ways we could import it on the front end.
Okay, but you have a compiled version of the model already, right?
Yeah, but it's pretty large, and
Oh,
let me
okay.
see. I don't think we can. I mean, we could, but yeah, I don't know why we don't actually. Yeah, that's a really simple thing to do. Oh, okay. Yeah, I just forgot about that, I guess.
Well, you said 10 megabytes though.
Yeah, this is after compiling it into TensorFlow Lite.
Mm-hmm.
So like before that, it's in TensorFlow, which it takes like way more memory, right? And it's way bigger.
Okay. And is it fine to use the TensorFlow Lite version?
Yeah, after that, it's completely fine. It's super fast after that.
Okay. So now you just need to find a way to link this to your native app.
Yeah. There are like two more things. We also need to compile it properly into TensorFlow Lite and run it on Docker, and then we just need to import it in React Native.
Why run it on Docker?
For testing.
Oh, okay. So you test, but you could test the compiled image on your PC, right? Maybe.
Yeah.
Okay. Okay. Because the goal is to get it to run, what, in the Android simulator, or I guess even Expo Go on your phone,
Yeah, on Expo Go.
on Expo Go, right? More realistic. Okay, cool. What do you think is the challenging part of this?
The most challenging part, definitely setting up CUDA toolkit, CUDNN, and other NVIDIA drivers for my GPUs. For
Mm.
me, that's like the biggest issue.
Oh
And
yeah,
after setting it up, I don't think we'll have a lot
but
of problems.
that's so far. What do you think is the most challenging part that you still have to do?
After these like drivers and setting it up, I think the biggest issue is the testing, because Google Play now requires you to have like 20 people test it,
Mm-hmm.
and also they need to like log in into the app every day for 14 days, and they have to like submit some stuff. So that's super unfamiliar for me, and I'm not sure how I'm gonna deal with that.
Wait, really? You have to have 20 people to test your app?
Yeah, it's an update which I think was released last month.
Oh. Play Console provides different types of testing tracks, so it's ready to go on the Play Store. Um, You must run a closed test before you can apply to publish. What?
Yeah, it's pretty ridiculous in my opinion.
Wait, but how do they know that those 20 people are like real people?
I do not know.
That's ridiculous. There must be something. There must be a service on Fiverr for this, right?
Yeah, 100% there is.
I don't understand. That's crazy. I mean, I've submitted things to the iOS App Store, and
Mhm.
of course, there's nothing like that. Um, on the iOS store, you spend all of your time just trying to get the certificates and the signing, the code signing correct. Um, but there's nothing with testing. You just pay for it. Okay, cool. I also have an App Store account if you need to. If you just want to use it to publish something, that's also fine. It's the it's the getting through the signing and all of that that's difficult. Wow. Okay. Yeah. No, I was just trying to figure out, what is it that I might be able to help with, basically, here.
You could definitely help us out with importing the binary file,
Mm-hmm.
which is image crop binary mask. It's compiled. I don't know where exactly, but basically we need to import it into the app context, or I'm gonna rename this later on. But basically into the context API, so we can like transfer the expo image files into NumPy arrays, which are actually cropped images and the binary mask. If that makes sense.
Mm. So in React Native, you have an image object,
Yep.
something like this.
Let me just see where it is. Using capture image function. Let me see. Yep. Expo image picker is an object. An object, I think.
And that's going to you want to actually run the binary and then pass in that image, right?
Yep.
As maybe through like standard input.
Yeah, and then like make sure that the binary is returning those two arrays, and then we need to feed those two arrays into the model.
Wow. Okay.
Yeah,
Yeah.
that's also a complicated step. Yeah.
Cool. Yeah. Okay. Do you have the binary work? Do you have like the binary working on the command line yet?
I think we tested it before,
Cool.
but I don't think it's with me. I think the other guy has it. I
Okay.
can send it to you later on.
Yeah, but that would be cool. Sure. I mean, it's a new thing to me, but that definitely sounds like something that I'd be down to like do with you. Definitely stronger on something like that than the machine learning side of things. But yeah, cool. That would be, maybe we can do like maybe whenever you're free, next week.
Yeah, sure. I would appreciate it. Especially because we don't have a lot of people on the front end. Most of the people are working on the model.
Oh, really?
hmm
Cool.
No one likes the front end for some reason.
Cool. Awesome. Um, what's your role in the team?
Um, I basically tried to lead this.
Hmm.
Um, I created like the teams. I invited some people, and I'm
Cool.
just trying to like assign tasks to people, and
Right.
I'm having my own too.
And now we're just trying to get it out the door.
Yep.
Would that be the first application out there that runs this um, melanoma detection model on a local mobile device?
Um, Using this architecture,
Yeah.
which is, let me see here, I
Yeah.
think so. And I like this architecture a lot because it's proven on non-medical data, and the accuracy is like 90%. It's ridiculous. Um,
Wow,
let me see where
crazy.
the accuracy is. So yeah, it's pretty crazy. I seen like some other apps on the Play Store, and they have um, I don't think they're using compiled models. I think they're just sending data to the cloud, and there's not a lot of them actually. But the ones that exist, there's like two of them, have like more than 300,000 downloads.
Okay, cool. And are those free?
Yeah, I think so.
But they're not GDPR.
I'm not sure. I'm
Oh,
not
they
sure.
might be licensed. Okay,
Yeah,
got
they
it.
might be licensed, so
Okay,
that's an
cool.
issue. Let me see if I can search them here. Um, yeah, so this is one. Basically, oh, yeah, there are some, but like most of these are not popular at all. This is the most popular one. It has 100,000 downloads. I think it has like 300,000, but okay, whatever. Let me see. Yeah. Yeah, they don't specify anything. I would like to be. Oh, actually, yeah, they pay. They pay $7 per week, so they're not free.
Got it. Okay.
Yeah, so we
Some
can
scathing
maybe.
reviews there.
Yeah.
This is why it should be open source.
Yeah, I would love to just make this open source, and like people can upgrade it as much as they want and just take care of it, so it can
Man, I
stay
love
free.
that. I love that. That's super cool. Yeah, awesome. Um, let's wrap it up for today.
hmm
And yeah, hopefully we'll keep doing this sometime soon.
Yeah, thanks a lot for having me. It's been an honor to talk to you. I saw that you were like super experienced and were coding since you were like 10 or something. So yeah, same thing when it comes to me.
I've learned more during this call than I've learned much more during this call from you than the other way around.
Yeah, this is just a very specific thing, but yeah, I'm sure you can help us out a lot. So thank you.
All right, cool. Well, I'm gonna hop on to my next stream in 2 minutes, and we are going to be making something else great for the world, which is a game where you can have Elon Musk and Mark Zuckerberg fight each other.
Yep, I'm gonna stick around definitely for that one.
All right. See ya.
See ya.